Okay, here's the notes. Writing notes. We're doing factoring, right? We're learning these factoring techniques. Factor or factoring, yeah. And today is difference of squares. Stephanie Escobar, are you here? Yeah. Oh, she's here. Can you pass this to Stephanie that way? Difference of squares. Write this down. Difference of squares. Okay. Now we all know what difference is. Oh, right. That doesn't say difference. What the heck does that say? What is that? Aviles. Difference. Oh, nobody saw that. Maybe you spelled it wrong too. Difference of squares. Okay. A difference of squares means this. A difference means that there's going to be a minus sign, right? Difference is like the fancy word for subtract, right? Sum is addition. Sum is add, addition. And difference is subtract. A difference of squares. Squares is not the shape square. Anybody know what squares we're talking about here? To the power of 2. Yes, very good. Squares is to the like something squared like this. Yeah? Like to the power of 2. You're right. Difference of squares. So a difference of squares is a difference of two things that are squared like this. Here's the idea, okay? This is a difference of squares, and you're like, what the? That's what's happening here. I don't like to teach it the way the book teaches it, but this is the way the book starts. I'm going to show you what I've been doing and how how it's going to be the same. But I'm just going to finish this because this is the way the book does it. Nah, you know what? I'm not. I'm just going to show you the way. Like I told you, you already know. Oh, okay. Ready? Watch here. This is what we've been doing. We've already learned product of binomials. I can give you a polynomial like this, and you can factor it out, right? Yeah, you can factor it out. Oh, by the way, remember we always look for a GCF. Yeah, there's nothing in common. There's no X in common. These two have an X, but this one doesn't. There's no numbers in common. But we already know this is the one with the product of binomials, yeah? We make a list of the factors of 14. Oh, yeah. This is like where you got to find the code, right? The two numbers that work here. Yeah, like having good number sense. So my list of 14 is 1 times 14, 2 times 6. Oh, that's it. Oh, this one's not going to take long. 14 is just 1 times 14 and 2 times 7. Everybody know which one we're going to use? Again, how do we know if we have to add or subtract the numbers? You look at this sign. The 14 tells me what numbers to write, the list here. But this tells me that from this list, I have to subtract the numbers to get a positive 5. Okay, does everybody agree it's going to be positive 7 and negative 2? Yeah. We already learned this. You guys are good. Okay. All right. Now let me give you another one. Number 2. What if I tell you x squared minus 8x plus 16? Well, you can do that too. Right? Well, let's see. What? I have to look at 16. 16 is 1 times 16, 2 times 8, 3. No, 3 doesn't go into 16. Oh, 4 times 4. And I think that's it. Do you guys see which one it is? Right here, right? This is a 16. These numbers add up to 16, and it has a plus. So I got to add 2 numbers here that give me a 8. What is it? 4 and 4. You guys see that? So what are you going to write? X, and then what? Negative 4 and negative 4, right? Is it, you guys agree it's negative 4 and negative 4? Yeah. Because I have to add up to a negative 8. So they both have to be negative. And sure enough, a negative times a negative is a positive. Okay. You guys good? So far we haven't started difference of squares. Here goes the difference of squares now. Watch number 3. Watch number 3. Ready? Look at number 3 here. X squared minus 16. That is a difference of squares. Now number 2 and number 3 are the same problem. You just don't see it. Ready? Here it goes. I'm going to open your eyes now. This is the way I taught you. Isn't x squared supposed to be the first part, or whatever the part squared is first? And then there's a middle term, and the number's supposed to be last? Yeah, so I want you to think of this problem like this. See, because there's supposed to be 3 terms. There's supposed to be 3 terms, but what happens when it doesn't have a, what happens if it doesn't have a middle term? Can't we write it like this, you guys? X squared plus no x. 0 means it's not there, right? You guys agree there's a 0? They're not going to write it. They're not going to write it when it's 0. But do you guys agree there's no, that middle term is not here on this one? So it's really x squared, and then this one, the minus 16 is back here. You guys agree with that? Yeah. Now you think of what numbers, which we have the list of 16 right here. Which numbers can multiply to this and add up to 0? Didn't we just use them over here? Yeah, but see, this will be x plus 4 and x what? Minus 4. They're going to multiply to give you the negative 16, but see how they're going to what? When they add, what happens? They cancel out. They add up to 0. They add up to 0. That's why you don't see. That's why you don't see this. That's why you don't recognize this one, because it doesn't have the 3 parts. But you kind of have to know. Oh, what's the part that's missing? The middle term. The middle term has to be a what? A 0. You guys see it now? Yeah. Yes? Okay, let's do another one. Number 4. How about if I put? Let's just change the letter just to be nice. M squared minus 100. Well, remember, you're used to seeing these with 3 terms. What does it mean if it doesn't have a middle term? What does it mean? Isn't it m squared plus 0m minus 100? Do you guys agree with that? You see what I'm trying to tell you? That means that the numbers that have to multiply to 100 also add up to a what? 0. And if that's true, what's another hint it's telling you? Well, doesn't it have to be the same number but opposite in sign? Opposites? Opposite of positive 4 is negative 4, so that they add up to 0, so that middle term is 0. What number multiplies to 100 and adds up to 0? M plus 10, M minus 10. So let's see. Why is this called the difference of squares? Because isn't it over here that 4 times 4, which is 4 squared, is 16? Yeah, these are square numbers. These numbers out here have to be perfect square numbers. Have you guys ever heard of? Yeah, we've heard perfect squares. Isn't 100 a perfect square number? Yeah, 10 times 10. All right. All right, let's do it this way. Let me do another one. Number 3. What about p squared minus, what about p squared minus, I think 225. Anybody know how to do this in the calculator? if I know that this is the scenario where it's p squared plus 0p minus 225, if I know that this is going to be a perfect square number, does anybody know how to find that out in the calculator? Well, let's see if it was 25. We know that if it was 25, isn't that 5 squared? You guys agree? It would be 5 times 5? Yeah, show me on the calculator how you would do that. Let me say I put a 25. Tell me how you get the 5. Can anybody tell me how to get the 5? You divide it by 5.
Divided by, wait. Oh, no, you don't know.
No. Nobody knows? Or let's say if it was 9. If it was 9, what is being squared for a 9? 3, right? You guys know 3 squared is 9. Okay, so you know the easy ones. You know the easy ones. But how would you find that out in the calculator? Let's say I put a 9. Can anybody tell me how to get the 3 out of that? Oh my God, nobody knows? Come on, somebody save the class. Or didn't we use 16 a little while ago? What's 16? What's a perfect square for 16? 4. Okay, how do you get that on the calculator so it can tell you that? Anybody know that? Ugh. Well, I'm not doing anything. Oh my God. Aren't these called squares? Squares? Anybody ever heard of this sign right here? This little thing right here?
I was trying to find it the whole time.
Well, I'm asking you what it's called. This little thing that looks like a...
It's a square root.
What did you say?
Square root.
Oh, did you say square root?
He didn't say what he said.
What did he say, Dean?
Oh, no, yeah, he got it right. I was looking at the actual button, not the thing on top.
Oh, you guys remembering now what that square root does?
Yeah.
If it's a perfect square number like 25, and I hit that square root thing, well, some of you have a button, but I got to do this. See, what's the square root? Oh, darn it. I got to do the square root first. Let me do that again. What is the square root of 25? Everybody, what's going to be the answer?
5.
Equals, look, 5. What does that mean? 5 times 5 is 25, yes?
Oh, okay.
What is the square root of 9? Let me see. Square root of 9, which we already know the answer is what? It's 3. What does that mean? That 3 times 3 is 9. Yes? And what number did I put here for us, for you guys? 200. I know you didn't know this. Why do you think I put this number? Okay, so how am I going to find out? I take the square root of 225?
Negative 225, right?
No. What is it, everybody?
15.
What does that mean?
15 times 15.
Ah, this means that if I did the square root of 225 and the calculator tells me 15, that means that 15 squared is 225. So tell me how this factors now, everybody. How does this factor? One of them's in a p and a p to get the p squared on the front, plus minus what? 15. See? 15. They're going to multiply to the negative because they're opposite in sign. That's how you get the negative. But they add up to what? 0 because they're opposites. All right, let's see if you know this one. Number 4. What about x squared minus... let me see. Hold up. I think you know this one. 169. Is 169 a perfect square root number? Is 100 there's only one way to find out. Tell me what to do. I take the square root of 169. If it is, it will give me a nice what? What does it say? 13. What does that mean? 13 squared, or 13 times 13 is 160. You got it, Chris? So what is this going to factor out to be? Again, remember, you have to know that this is really the one with a 3, but the 0 is what? Or the middle term is not there because what? Because they add up to 0, right? They cancel out. Do you guys understand how I'm showing you? You have to still see it as the one that has 3, but the one when it has like this tells you a big hint. They're going to be The same number, 13, 13, but 1 plus and 1. You guys see how this is going? Are we good now? All right. Okay, now do 5 and 6 at the same time. Ready? 5 and 6 at the same time, because this is where they're going to fool you now. 5 and 6. Ready? What if I tell you this? A squared minus 64 is not the same as 64 minus a squared. A ver, tell me the difference, or do these right here. You got it, Chris? Okay, give everybody about 10, 15 seconds to think about this. Is this the exact same problem? It is not exactly the same problem. Okay. Now I'm going to kind of do it the way the book shows you, okay? The book says this. The book says this. If you know that it's a difference, which is a subtract, and you figure out what's being squared here and what's being squared here, which is, I know that that's what you're thinking, then you'll get it. Can somebody tell me what's being squared here for the front? Just an A, right? And can somebody tell me what is being squared here? 8. If you can figure out the parts that go here, then it factors out like this. A, 8, 8, plus minus. Isn't it the same thing that I'm telling you? Yeah, it is. If you're convinced that this is a difference of squares, you just got to figure out what's being squared here and what's being squared here. We got it? So that's correct for number 5. But why is this one different? Can somebody, Christopher, why is this one different?
Put the 8 where the A is and the A is.
So this one, the 8 is in the front and the A is in the back. You guys see it? So should I write it exactly like this? No. How should this one be written? How should this one be written? Well, see this one, the A was here in the front, or the A is positive. This one's the one that has a negative. This one should be what? What should be in the front? The 8s should be in the front. Then the plus minus, and what should be in the back? Yeah, that's how they're going to try to mess you up. Whatever's in front stays in the front. Whatever's in the back stays in the back. Okay. Ready to step it up a notch? Here it goes. What about this? Number 7. What if I tell you 25x squared minus 9? Oh, yeah. Are you convinced that this is a difference of squares? Maybe some of you might like it that way better. Chris, you got it already? All right, hold on. Give everybody a chance to think about it. Is this something that is a perfect square term, and is the back also a perfect square?
Yeah.
Okay, what did you get, Isma?
5.
5?
X.
Correct. Everybody good with that? Everybody agree with that? Yeah. And, I think we know what this one is. 3, right? 3. If you are convinced that this is a difference of squares, how does it factor out, everybody? What goes in the front? No, not just X. Okay. And what goes in the back? And then 1 plus 1 minus. You think you got it? Last one, 8. Last one, 8. How How about, let's see, I'm going to put one you don't know. $289 minus 4a squared. Well, we have the difference part. Can you tell me what is being squared here? Because if you can figure out what goes in here, we can get it. Well, I'm going to do the easy one first. This one. Anybody get this back? This part. What's being squared here to give me a 4a squared? A 2 and a 1a. Correct. And I don't know that. But my calculator knows the square root of 289. Enter. It says 17. Well, then it's 17. And if you figured out this, then how does the difference of squares factors out? With 2 parentheses, but you got to write it correctly. How do I write this? 17 is in the front, so 17 is the front. 1 plus, 1 minus, and, yeah, 2a. You guys see how those work now? All right. Okay, good. I think you got it.